Hey everyone. So, we're going to talk about something really cool today in the world of AI. Think about this. How do we get AI agents to do more than just follow a recipe? How do we teach them to actually learn when they mess up? Learn from experience. It's a huge challenge, but some new research might have just cracked the code.
So here's the big question. How do you teach an AI to learn from its own mistakes, not just, perfectly copy an expert? We're talking about getting an AI to have that real aha moment when something goes wrong. It's not just about memorizing the right moves, it's about understanding why the other moves were wrong in the first place. And that's exactly the puzzle a team from Meta and the Ohio State University decided to tackle.
All right, so we've got an AI learning dilemma on our hands. To really get why this new idea is such a big deal, you first have to understand the two main ways we've been trying to teach AI agents. And spoiler alert, both of them have some pretty big roadblocks.
Let's break this down with an analogy. Imagine two types of AI students. First up, you've got imitation learning. This is your perfect copier. This student just watches an expert, right? And it learns to follow their examples perfectly. It's great at mimicry. Then you have the other type, reinforcement learning. This is the final exam taker. This student just tries stuff over and over and over, and it only finds out if it did well at the very, very end. Just a single pass or fail grade for the whole thing.
So, what's the problem with being a perfect copier? Well, for one, it's super brittle. The second it runs into a situation it hasn't seen before, it completely falls apart. It's never made a mistake, so it has no idea how to recover when it does. And on top of that, think about it. Getting humans to create all those perfect examples, it's crazy expensive and takes forever.
Okay, so what about our final exam taker? Yeah, that has a whole other set of problems. Think about trying to do something complex, like booking a trip online. There's no one telling you, good job, after you pick the right departure date. You only know if you succeeded once you have the tickets in your inbox, right? That lack of feedback along the way, what researchers call a reward signal, makes learning super, super inefficient and, honestly, pretty unstable for anything with a lot of steps.
So you have the copier and the exam taker, and both are struggling. What if there was a third way? A bridge between these two approaches? Well, that's where this new paradigm comes in. The researchers call it early experience.
And this timeline really lays out the whole idea beautifully. On the left, you've got the past, the era of human data. That's our imitation learning. On the far right, you've got the future, the era of experience, which is where reinforcement learning shines. And right there in the middle, that's early experience. It's the missing link, the bridge that lets an agent learn from its own actions to get from one side to the other, all without needing that final exam score.
So what is early experience, really? At its core, it's a beautifully simple but really powerful idea. It's a training method where the AI learns from the consequences of what it does. It tries an action, it sees what happens, and that outcome becomes the lesson. No external reward, no pass-fail grade from a teacher. The experience itself is the teacher. Okay, so how do we actually get the AI to learn by trying? The researchers came up with two really clever strategies to make this happen. Let's break them down. Strategy number one is called implicit world modeling. The best way to think about this is like doing practice problems before a test. The AI is constantly asking itself, okay, but what would happen if I did this instead? It then runs that action in a simulation, sees the result, and learns to predict these outcomes. Over time, it starts building this internal model, this gut feeling for how its world works. This second strategy is even cooler. It's called self-reflection. This is like when you get a test back and you go over it with the answer key. The agent looks at a move it could have made, compares it to what the expert actually did, and looks at the two different outcomes. But here's the amazing part. It then writes out an explanation for itself, a rationale, explaining why the expert's choice was better. It is literally teaching itself the logic. And this isn't just some abstract idea. I mean, look at this. This is a real example of a self-reflection note an agent wrote for itself on a web shopping task. It says, while the red shirt matches the color preference, it exceeds the $20 budget constraint specified in the query. The blue shirt satisfies both the style requirement and budget limit. See, it's not just learning pick the blue shirt. It's learning the reason why. It's understanding the budget constraint. And that's a lesson it can apply to any other product, which is way more powerful. So, all this theory sounds amazing, right? But the big question is, does it actually work in the real world? Well, let's look at the results. And when they tested this, they didn't mess around. They ran these agents through 8 completely different and really complex environments. We're talking everything from navigating websites and online shopping to scientific simulations and even planning travel. This was a serious stress test.
And the results? They were pretty stunning. Just take a look at this one task, the web shop benchmark. Your standard imitation learning agent, it only succeeded about 47% of the time, less than a coin flip. But the agents trained with these new early experience strategies, boom, they shot up to nearly 59% success. That is a massive jump, and it came just from letting the AI learn from its own trial and error.
But honestly, this next part is the real game changer. It turns out that early experience doesn't just make a better agent right away, it makes a better student for the future. Check this out. After this initial training, they then applied traditional reinforcement learning on top. The old model topped out around 80%, but the agent that started with early experience, it soared to over 91% success. It proves that a better start really does lead to a much, much better finish. Okay, let's step back for a second. Smarter AI agents, a smarter world. What does all this research actually mean for you and me? Why does this stuff matter? Well, for starters, this can mean way more helpful and robust digital assistants. Ones that don't just get stuck when you ask for something slightly weird. This opens the door to AI that can actually explore a new problem and figure things out for itself. And this is a big one. It makes training AI way more efficient because we won't need to rely so much on incredibly expensive human data. Really, it's a huge practical step towards those more general, more autonomous AI systems we've all been hearing about. So there you have it, a quick look at this really fascinating new way of teaching AI. But now I want to know, what's your take? Let's talk about it in the comments. Here's a question for you. If you had an AI agent that could really learn and adapt like this, what is the #1 tedious, annoying task you would immediately give it? Would you have it plan that complicated vacation for your whole family? Or maybe navigate some horrible customer service website for you? Let me know down in the comments. I'm genuinely curious to see what you all come up with. Thanks so much for tuning in.